Welcome. We're going to talk a little bit more about research designs this week, and a lot of this is framed in terms of experiments, although just like last week, I'm hoping that the lessons that we get out of this are going to be much more general than just running experimental studies. Make sure I'm recording here. I am. Okay. Um, yeah, so last time uh, we took a look at what experiments are and what they're for, and I told you that experiments fundamentally generally only answer questions about the difference between two or sometimes more than two different things, right? So you can't really use an experiment to show that two things are the same. You're really comparing, one set of measurements with another set of measurements and trying to show that they're different in a particular way. And as we mentioned last week, a lot of experiments, especially in linguistics, are actually about differences between differences. And these are referred to as interactions. So if you recall this picture from the last set of slides, we are in two different conditions of interest here. Maybe these are different teaching interventions, maybe they're different languages, maybe they're different sets of sounds we're looking at, or linguistic constructions. And then within each condition here, maybe we're looking at a difference between people or a difference between two items. And the simple contrasts here are going to be x versus y under this set of conditions and x versus y under this set of conditions. But oftentimes, or comparing y and y, y in this condition with y in this condition, comparing x in this condition with x in this condition. But often what we're going to want to know in experiments like this, and I'll give more examples later, is whether the difference between x and y in this condition is itself different from the difference between x and y in condition B, right? So this would be the interaction of the xy contrast with the AB contrast. And this is often the kind of study that we want to run in human, social, and behavioral sciences, including linguistics and language education and fields like that. And so one of the overarching points here is just that, these are not sort of straightforward physics experiments or something like that, which can be very hard to set up, but are generally quite easy to interpret. Instead, our experimental setups when we work with people get really, really complicated really fast. Here, we're going to go through a couple important design principles this week. And the first super important one here is the distinction that's generally made in the human sciences between within subjects designs and between subjects designs, where the within subjects one is sometimes referred to as repeated measures design. And here's what this refers to. When we do an experiment and we're measuring the difference between two things, A and B, are we measuring different people in the A condition and the B condition? If so, that would be called a between subjects variable or a between subjects design, if that's the only variable in the experiment. But the idea here being that we're varying this comparison of interest, A versus B, but we're not doing it for a single subject. Instead, we're putting some subjects in the A condition, some in the B condition, and so the comparison of interest, A versus B, is going to be a comparison between subjects. The alternative, are we measuring the same people under two sets of different circumstances, A and B? That would be a within subjects or repeated measures of some outcome under different conditions. We call that a within subjects variable or within subjects design, because again, the comparison of interest here, A versus B, is happening internal to a single subject's data. It's within subjects. And we're taking repeated measurements from each subject. So why is this difference important? Well, it's important because A, these are both feasible designs in most human studies, although we'll see some exceptions later. And they're also important because the concept subject, the person doing the experiment, has to be treated statistically in a very special way. And I'm not going to go into great detail about statistics in this class, but I will talk a little bit about statistics in this particular lecture, just because it's important to understand a few issues that underlie this. Not going to be much technical material. So the concept subject in particular needs to be treated as a random variable. in statistical analysis. And that has very different consequences in these two designs in ways that I'm not going to get into in detail, but it's a really thorny and interesting and tricky issue in the statistical analysis of experiments. And that's part of the reason why these designs are important, why the difference between them is important. But I'm going to focus more on the conceptual side of why the differences are important. So here's an example we looked at last time. Is the use of nouns embedded in real life sentences a good method for teaching grammatical gender compared to simple rote memorization? This one, presumably, if it's a well-designed experiment, is going to contain both kinds of variables. And so this one is going to be neither entirely within subjects nor entirely between subjects. And this, again, is very, very common in linguistics. And so that you can call this a mixed design or a mixed effects kind of an analysis. And the idea here is that we're mixing within subjects variables and between subjects variables. So we're looking at goodness of a teaching method, so we're probably going to need to look at a pre-test versus a post-test. That is, how good are people with gender in this foreign language before anything happens, and then how good are they after our teaching intervention, right? The question here is, do they improve? That's how you judge the goodness of a teaching method. And that's going to be a within subjects variable because everybody is tested twice under different conditions, and that's happening within each subject's data. But the instruction method here, the use of real life examples versus just rote memorization, that's a between subjects variable. Why? Because some subjects are taught one way and some subjects are taught in a different way. And when you compare those two methods of teaching, you're going to need to compare between different subjects. So this is a mixed design that involves both within subjects and between subjects variables. And this is very, very common in linguistics. So in general, the drawbacks of within subjects versus between subjects designs and their advantages are going to be the same as the as the advantages and disadvantages for any particular variable, right? So there are some advantages to doing a variable within subjects. There are some advantages to doing it between subjects. So let's start with the within subjects variables and the within subjects design. What's good about this within subjects design? Well, it's more efficient because you don't need to gather as much data from as many subjects. And so it's just a more practical, more efficient way to run experiments. You can get more statistical power, which is the ability of statistical tests to correctly detect effects that exist. Right? So that's a technical issue that we don't need to go too far into, but basically you get better statistics out of doing within subjects designs if you use the right statistical model, which ends up being pretty complicated. And I've highlighted this last one because it's probably the most important reason why you might prefer a within subjects design. It's impossible for group assignment to interfere with the results. Why? Because there are no groups. Every subject within subjects design is treated in the same way, right? And so we don't need to worry about differences between groups. We're going to focus on that in detail a little bit later. But that is perhaps the most important single reason why you might want a within subjects design if you can. Now, drawbacks, statistical models can be complicated. In this class, we're not going to get to the level of running statistical models of data, but in general, this is a thing, right? Within subjects experiments just have more complicated statistical models. The conditions could change in between your repeated measurements. This is a recurrent problem in some within subjects designs. You can think of it as poisoning the well. Maybe the things that you do to subjects at time one change the way that they're going to respond to a different condition at time two. So that can be a problem. And then finally, sometimes the relevant conditions just can't be applied to a single person. And I'll have some examples of that as well. It's not always possible to do it within subjects design. So let's elaborate on this a little bit more. These drawbacks, while they exist, none of them is insurmountable. So statistical models can be complicated, but there are good models of within subjects designs. And the hard work here is going to be done by your computer software. Nobody is sitting here running statistical analyses of experiments by hand with a pencil and paper or anything like that. As long as you know how to use your statistical software, okay, this shouldn't be too much of a problem. Conditions can change in between repeated measurements. This is a real concern, but it can often be controlled for using counterbalancing. What does counterbalancing refer to? It means that if you're testing people in more than one condition, then you make sure that some subjects get the two conditions in one order and some subjects get the two conditions in the other order, or generalizing to more than two. If you're doing more than two conditions, you make sure that subjects get them in all the possible different orders, and this helps ensure that you're not unduly influencing the measurements in one condition based on the time at which it was done in the experiment. And so this is super important in within subjects designs. If you can counterbalance the conditions, then do so. Right? So this helps alleviate our concerns. Now, you might still get interference between the conditions, but now at least because you varied the order in which people did the experiment, you'll be able to look at the data and see those effects. Right? You'll be able to tell whether or not this is a problem. Between subjects designs, well, the advantages here is it will allow us to study a wider range of variables, because as we'll see shortly, there are things you can't study within subjects design. Generally going to involve simpler statistical models, and there won't be any confounding effect of which order the different measurements were taken in, because there are no different measurements. There's basically just one measurement per subject. The cons or the drawbacks of this approach, and these are big. We're going to elaborate on these a lot. So drawback one, how do we know that the only difference between the two groups is the variable of interest? Right? If we put some people in the learning examples from real life educational program and other people in the memorizing things by rote from a textbook learning program, we find some difference between those two groups, but how do we know that the relevant difference between those two groups is just the educational intervention that they were given? We don't know that because people differ in an infinite number of fine-grained ways, some of which are going to be relevant to learning outcomes, some of which aren't. And related to this, when you run a statistical model correctly on a between subjects design, you end up with less power to detect real effects that exist. And that's because of this fact that we don't know whether to attribute the differences between condition A and B to the manipulation of interest that we're trying to study in the experiment, or whether we should attribute it to the fact that people are different from one another. It makes the design less quantitatively powerful. It's also conceptually very problematic, as we'll see later in this lecture. In particular, there is a problem, this general problem, that we never quite know whether differences between groups are due to experimental manipulations or whether they're due to the fact that people are different. And you can refer to this problem as selection bias. And here's a way of stating this. Any two groups of people may have different average characteristics that affect the outcome of an experiment, independently of anything you do in that experiment. The problem is especially bad if subjects select their own groups, and I've put select in scare quotes here because this is not the everyday English meaning of select that I have in mind here. This is a kind of specialized technical meaning where it doesn't require people to exercise active choice. It just means that the ways in which they're assigned to groups has some sort of systematic bias to it, right? Or some sort of systematic asymmetry. Right? So here are some examples, and see if you can think to yourself why each one of these is problematic from a group selection standpoint. So here's case one. Are private school students better at math than public school ones? So we're going to obviously be studying different students here, and what's the problem? We find a difference where one group is better than the other group, and we conclude that kind of school is better at teaching math. What's the problem? Problem here is that before this experiment ever started, one group of students chose, or their parents chose, or some set of societal forces chose to have them attend either a private school or a public school. And before the experiment ever started, your group of private school students was probably very, very different than your group of public school students. And so you don't know whether differences in math skills are due to the private school versus public school distinction, or whether they're due to the fact that these two groups are really different from each other. Second example, do parents who drink excessively have children with health problems? Again, what's going to be the selection bias problem here? Well, parents who drink excessively chose to drink excessively, and parents who don't drink excessively chose not to. And again, I'm using chose here in what I'm attempting to use it in a non-judgmental, not active choice kind of way. I mean, people with drinking problems don't necessarily choose to have drinking problems. That's not what I mean at all. It just means that there's some set of behavioral features that put people in one group as opposed to the other group long before the experiment started, and you don't know if any differences in the children have to do with the drinking per se or have to do with the other differences between drinkers and non-drinkers. Here's a real life example, this last one. Do people who eat meat die younger than those who don't? The answer is yes. This has been confirmed over and over again. So can we conclude that eating meat causes you to die younger? The answer is no. Why is that? Because again, this is not a controlled study where you're making some people eat meat and making other people not eat meat. These are observational studies where you basically measure people's health outcomes, and then you have a questionnaire about how much meat they eat, and you see whether this group of lots of meat eaters die younger than this group of not lots of meat eaters, and you find a difference between them, but you don't know whether it's due to eating meat or due to general differences in other kinds of lifestyle factors between people who eat lots of meat and people who eat less meat, right? It's impossible to say which one of these causes the difference. Right? So this kind of selection bias kind of a problem that arises in between subjects designs is really a serious problem for these designs. So I would say, while there are both kinds of designs out there in linguistics and cognitive science, it's always good practice to prefer within subjects designs wherever they're feasible, because these problems with between subjects designs are really, really tough to overcome. And the reason why is inherently tied up with the issue of correlation and causation. So we're going to get to that in the next part of the lecture.